Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with DevExpress controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 456. In this episode, Scott talks with Adrian Rosebrock about computer vision.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I am talking with Adrian Rosebrock. He's a PhD in computer science and focuses on computer vision and machine learning. How are you?
I'm awesome, Scott. Thank you for having me. This is really, really cool.
Oh, wow. Well, I think it's really cool that you have a PhD and I went to community college, which is pretty exciting because it's not every day that I get to sit down with people who are this smart, but more specifically, people who are really into a topic that I'm interested in, and that is computer vision.
Oh, yeah. Computer vision's a really, really cool course or a really cool subject. And not many people really realize how prevalent it is in their everyday lives.
Yeah, it seems like an almost impossibly magical thing, you know, like if you're a programmer, like you're listening to this show, your life is for loops and the occasional if statement. It's not super sophisticated, with all due respect to the people who are listening. The leap between basic, I'm looping through some records. I did some CRUD. I learned some Ruby and I recognized a face on 30 frames a second high def video. It's just like, I don't even know where to start. How do you teach a computer to see?
Well, that's an interesting topic. I mean, computer vision, captures and studies so many different areas: the acquisition of an image, how to process an image, how to find objects in images, and there's all types of subfields around it. And for humans, it's really easy for us to look at a picture of a cat or a dog and recognize instantly, hey, that's a cat, or hey, that's a dog. But for computers, it's not like that. All they see is a bunch of pixels. So one of the main goals of computer vision is image understanding, being able to interpret the contents of the image.
And the quality is very iffy, like in the sense of you might think that a computer could recognize a face because it's a super high res picture, and while people could look at even like 100 by 100 black and white and still kind of make out that maybe someone's there, does the image quality matter a lot?
In some cases it does, in some cases it doesn't. It really depends on your application. If you're doing real cellular analysis, if you're working in a biological sense, you need extremely high quality images that could be gigabytes in size as they're compressed. So it's incredible the amount of data you can get working in the biological sciences with computer vision. But on the flip side of the coin, sometimes actually resizing the image and making it smaller actually improves algorithm performance. It allows you to kind of downsample, make your algorithm a lot more efficient. It's kind of like looping over records in a database. It's faster to loop over a smaller amount of records than a large amount of records. The same is true with computer vision. Sometimes it's faster to work on smaller size images.
So that points out a couple of interesting, kinds of problems that computer vision can kind of help solve. On the one side, I think about it in the terms of there's a stream, like some video, the kind of the classic people are walking by a camera in the mall. And if you see a person, you can say, hey, how are you? Because you saw that person. It's many frames a second, very fluid motion. And then on the other side, you've got, like you said, gigapixel sized images of cells. Are those very different, or is the same same core concepts shared?
They're very, very different concepts. If you're working in those types of large cellular structure images, the techniques you're going to use are substantially different. You're probably going to be working with very large mainframe systems or distributed systems, as opposed to if you wanted to build a simple system to track people walking in and out of your apartment or office, you could run that on a small little Raspberry Pi. It doesn't take a lot of processing power to build something like that.
Really? So I could recognize faces or heads and maybe turn on a camera with as little processing power as a Raspberry Pi?
Yep, you could connect that Raspberry Pi to the internet, and when someone walks in through your front door, you could send them a tweet and be like, "Hey, welcome to my house. Sit down, play a game."
So let's cover that kind of low powered, high, a lot of frames going on at the same time question first, and then we'll get into the medical stuff. That might be 20, 30 frames a second. Are you looking at every single frame?
It depends on the algorithm you're implementing. A lot of algorithms will try and obtain real-time performance. So if you're working in, a compiled language like C or C++, and you're generating these binaries, it's possible to look at every single frame. And as long as you're not doing too much. For simple face detection, you can actually do real-time image processing. And I think one of the coolest success stories of all time, at least on the consumer side of things for computer vision, is the Xbox Kinect. I mean, this is something that can interpret your body motions and allows you to be a controller, and that absolutely requires real-time performance. And computer vision has really just solved that problem. It's amazing.
Why do we see kind of weird things, though? Not to have you pick on the Kinect folks at all, because everyone in the space agrees it's amazing, but then every once in a while, my leg will just fly up by my head. And it's just like, what was it thinking? I'm clearly not doing that.
Mm-hmm. And that's kind of a weird thing to try and teach programmers. At least that's what I've struggled with personally is, to a programmer, 2 + 2 is going to equal 4, or you can write a function to generate a Fibonacci sequence. And once you write that function, that's always going to be the correct answer. When you start doing a little bit more advanced concepts, in computer vision and machine learning and advanced topics in computer science in general, it's not always clear cut like that. There are edge cases that are based on probabilities when things aren't going to work out the way you want them to. And that's a really hard concept to teach.
So then you get into this kind of, is it called fuzzy logic?
It's to a degree. It's not exactly fuzzy logic. In terms of the Xbox Kinect, it's really based off of probability estimates.
I see. So they're basically saying there's an X percentage chance that his foot is up by his head, and something in this case triggered that threshold, and it went, over the threshold, and then it said, okay, well, our skeleton processing detected that his foot's up there like that.
Right.
It could have been a glint off of a window behind me or something that got it confused.
Yep.
So you can recognize faces. What else can you do with computer vision?
Well, it's really cool when you think about it, because you normally think of computer vision in kind of like a surveillance or security point of view, where you want to know if someone's breaking into your house, or you want to know if someone's trying to rob a bank and you want to call the police. But there's also a less, I'll say, scary side of it, or it may actually be scary depending on your opinion on this story. But imagine you're in GameStop and you pick up the latest edition of Call of Duty, and GameStop has these security cameras mounted around their store, and they could read what's your facial expression when you picked up that game. Were you interested? Were you unhappy with it? Did you put it back down? Did you take it to the counter and purchase it? So you see this type of stuff in retail stores. And they're gathering this information. They can actually kind of perform a motion detection and determine what people are interested in. So it's pretty interesting from that point of view.
Are they doing that, or is that something that they could do?
That's something that a few companies are just starting to get into now. It's a new field. It's not as easy. But you see it a lot in kiosks. So you go up to Best Buy and they have a little motion detector that says you just walk by this kiosk, and a presentation pops up about the latest iPhone or whatever. So they're combining motion detection with computer vision to analyze your facial expressions to see how you react to different products. And then all that's relayed back to the company for big analytic processing.
Yikes, that's really powerful. It has some interesting privacy ramifications. It'll be interesting to see if they can do that in such a way that we all appreciate it and that we don't find it creepy.
Yeah, for sure.
Yeah. I also have seen the real-time translation applications where someone will hold up a sign in Spanish. I'll point my smartphone at it, and then it actually overlays the English over that sign. And that seems almost impossible, because they even replicate the font and things like that. And it all happens in real time.
Yep. That's a pretty interesting topic. It's called OCR, or optical character recognition. It's basically the process of holding, as you said, a piece of text up to a camera, and the camera is able to not only find the text into the image, but convert it into like a string variable type piece of text that you can perform normal operations on in a computer vision or a computer science take. So it's really, really cool to see what they've done. I've seen wine apps where you can actually, it scans like the entire wine menu and then gives you the ratings right next to it, so you know which wine to order in a restaurant.
So that's what's they call that, augmented reality?
Mm-hmm.
So it's seeing what you're seeing and then providing additional information and recognition and classification of that.
Yep.
That makes me feel like we might be able to see like a Google Glass or something like that, where I could, pick up my Call of Duty, like you said. Maybe they're using computer vision to detect whether or not I want to buy it, but maybe my phone or my Google Glass is going to show me a cheaper price, down the street and hover that price over the product.
Exactly. And we do that already. And Amazon does this type of stuff in their Amazon Flow app. You could hold up a cover of a book or a Blu-ray disc and take a picture of it. And Amazon will say, like, here's the price of what you just showed me right there on your device. And why would you go to Target and spend an extra $10 on it when you can get it from Amazon for cheaper and have it shipped right to your door?
Is it true that people are using this to analyze like football games and see how the people are moving on the field and getting a sense of, the flow of the game? Yep,
for sure. There's a whole field related to sports analytics, and computer vision plays a big part in that, especially in football games and soccer games overseas in the UK. They track players as they move. They track how the ball passes, and they look for ways that they can beat the other team.
So if I'm listening to you, I'm listening to this podcast, and I want to get involved in this space, do I just jump in and get a library, or do I, and this might be oversimplifying, do I just go into Paintbrush, draw a black circle, and then try to write some code that finds that black circle, and then get at the basics? Where's Hello World when it comes to computer vision?
Right, and that's the cool part, is that computer vision, while it seems like an advanced field, has been around for a very long time. And we have this library called OpenCV. It's like the de facto standard for learning computer vision. So when you're learning computer vision, you don't want to have to learn low-level information, like how do I load a JPEG off of a disk and decode it and then display it to my screen and then write it back out in PNG format. That's a waste of your time. And if you're just getting started, you should be really, as you said, developing the Hello World type of stuff. So there's OpenCV. If you're in the academia world, you might be using something like MATLAB and the Image Processing Toolkit, although people are starting to really move away from that over to Python now. And if you're working in the biological sciences, doing some cellular analysis, there's a program called ImageJ, and that was developed by the National Institutes of Health. It's more of a point-and-click approach to image processing. So you'll go to a submenu and select, I want to detect edges in this image or whatnot, and then it does the result for you. I refer to it as Photoshop for image processing and computer vision, but it's obviously a lot more advanced than that, but it gives a general idea of what it is.
I see. So let's say that you're working with a doctor. The doctor might use the point and click to kind of train it and point out a few things and then give you that model, and then you might, modify it and do it in code to be more efficient or more correct.
Right. So ImageJ does take a basic level of image processing knowledge to understand, but you don't have to write any code to do anything. It's very point and click based.
Now, you mentioned that it's looking at that MATLAB is something. Does this become just like arrays of bytes in memory? Like at the root, of course, you're going to load up this grid with color depth and alpha and all that kind of stuff, and it's all matrix math, isn't it?
Yep. It's entirely matrix based. An image is just a multi-dimensional array, and there's tons of libraries that are optimized for these multi-dimensional arrays, no matter what programming language you're using. So it often leads to very, very fast algorithms, including real-time processing.
Now, you mentioned OCR. I remember in the maybe 93, 94, when I very first got a scanner and I did OCR. This was black and white. This was before grayscale. And I was absolutely blown away. But it would take 15, 20 minutes to go and OCR a page, that we got faxed to us. But now you're seeing OCR and image processing that's happening like you said, in real time. Is that just a matter of processing power, or is that a matter of math people getting smarter and algorithms getting faster?
It's a combination of both, for sure. Computers are definitely getting faster. There's no doubt. And our algorithms have gotten a lot smarter.
Okay, so we're not just for looping around a multi-dimensional array in the most inefficient way possible anymore.
Correct.
So OpenCV, that's the canonical place to start.
Absolutely.
But you said you're using Python, though. Why? I think of Python as a scripting language.
Python is actually one of the most used languages for computer scientists who are doing research or that type of stuff. It's amazing the amount of libraries that Python provides. So one of the main reasons I recommend Python is that it's an easy language to learn. It's forgiving, and you can get a lot done very, very quickly. So maybe you're not going to get the performance you would get if you wrote it in C or C++ and compiled it down to a binary, but it allows you to prototype really, really quickly. And in many cases, the Python code is going to run fast enough anyway. And
probably because computers are faster as well. And it's like you said, it's fast enough.
Exactly. And if you need any type of machine learning on top of it, you have tons of libraries at your disposal.
I see. And then it removes that barrier to entry that a C-based language might cause.
Yeah, it's amazing that a scripting language, a loosely typed scripting language like that, can do such amazing things with the libraries that are out there.
Would you go to production with Python in computer vision, or would you prototype in Python and then move to something else once you've got it nailed down?
So for me, I tend to go to production right in Python. That's because a lot of the stuff I've developed acts as an API or a service, so it kind of just gets deployed to the cloud, and people can interact with the API that way. If you were developing a real-time application, then that might be an issue. So you might want to write it in a compiled language and distribute the binary. Or if you're kind of licensing your software and distributing it out to people, you can't really do that effectively with Python because you're worried about people taking your code and running with it.
Okay, so there are cases where Python would not be a good choice.
Oh, absolutely.
For a application. A couple of days ago, I got a check in the mail for, rarely you get a check, right? And the option was either take the check to the bank or take a picture of it with my phone and send it up and deposit it. So I assume that image was sent in some presumably fairly high megapixels, some high resolution, sent off to the bank, and some image processing was done on the back end. Because one of the checks was rejected. They said that it was crooked when I took the picture, and they wanted me to take the picture again of the check, which I thought was pretty impressive. Another one I forgot to sign, and they didn't know. They said, well, you need to turn around and sign this. How are they knowing? Those things seem very application specific. They are, and some of the most advanced computer vision applications are very domain specific. For example, check recognition. There's a lot of heuristics that you can, and domain knowledge you can apply. You know that check is a rectangle, so you can look for rectangular structures in the image. And you know that the signature is going to be on the bottom right-hand corner, and you know that there's going to be a little box where you write in the amount that the check is for. So you can apply your domain knowledge with computer vision, and then that can help you out a lot as opposed to kind of a free-for-all approach. I see. So I'm trying to put this all together as far as like this. I want computer vision to be another tool in my toolkit. So for example, if I were doing speech recognition, and I wanted to make it so I could understand 3 or 4 words, it would be foolish for me to drop in a generic all the words in English speech recognition system because the user is only going to say 3 words. I want to constrain that domain. So applying that same kind of thinking to computer vision, they're not taking pictures of CDs. They're not taking pictures of faces. They're taking pictures of rectangles. Checks are always rectangles. So am I going to build like a flow chart from a business person's perspective about what are the characteristics of a check that we want to tell the user about? Yep. There's always, for problems like that, there's always some sort of underlying assumptions that you're going to make. And the more of those assumptions you make, the more domain constrained your problem becomes. But in the case of, recognizing checks, that's actually a good thing. It allows you to build those algorithms quite effectively. So if I am not a scientist and I don't have this level of understanding that you do, but I still want to write, we'll use the check writing as an example. If I want to write something like that, would I be able to do a fairly decent check writing, recognition system with something like OpenCV? And what would that code look like? Would it be each of the characteristics would be separate subsystems that would go and check, or would it be one giant function? I mean, give me a sense of how I would create a check recognition system rather in something like OpenCV.
Okay, so again, you would start off with your assumptions. So you would assume that a check is a rectangle. So a rectangle has 4 points, and you're going to load up your image off of disk. You want to convert it to grayscale rather than using the RGB coordinate system. And the reason for that is you're only interested in one channel of the image realistically. So you can throw away all that color information.
And I assume I think that'll speed things up then too.
Yep, absolutely.
Okay.
So that once you have it in grayscale, you want to do what's called edge detection. You want to find edges in these images. So in this case, when you perform edge detection, you'll find the outline of the check. And then you'll make an assumption again that a check is a rectangle. It has 4 points. So I'm going to find the outline in the image that has 4 points. And I'm going to assume that the largest outline in that image that has 4 points is my check. So
because there could be a business card on the table that they took the picture of the check with.
Mm-hmm.
I didn't even think about that. And that would also make me assume that it would be easier to take a picture of a check like on a kitchen counter as opposed to me holding one up in front of a bunch of picture frames, because you might think that some photograph on the wall was the check.
Mm-hmm. And due to holding the check, you might increase or insert a tiny bend in the check, which may throw off the approximation of the outline. So that's again, it's all about the underlying assumptions. Just as you're building a normal program, you have assumptions regarding the input and output of functions, and computer vision's the same way.
Okay. So then I would go looking for maybe the account number at the bottom, which I know is in a certain font because everything in the checking world is using that specific account number font there, right?
Yep. So once you have the image or the check found in the image and you're looking down on it, you're going to look at the bottom portion of the image to find that series of text. And you'll do the same type of thing all over again. You'll apply some edge detection. You'll find each of the digits on the check, and then you'll pass that off to your OCR, your character recognition subsystem. That's probably something that there are libraries that exist that already do that for you. Or if you wanted to build your own, it wouldn't be too challenging.
Mm-hmm. So let's say that I put this into production then, and I discover that maybe a new kind of check comes out and my algorithms have maybe some hard-coded things, and I make some assumptions, and suddenly I'm unable to see, the check number in the corner because this new kind of check, it's closer in or something like that. Would I want to, when I created my computer vision application, have a series of thresholds and a series of inputs where I could basically adjust it to make sure that my rejection rate is not too aggressive?
Yeah, absolutely. You can certainly do that. For situations like that, I recommend trying to recognize what type of object it is that you're looking at. In this case, checks. So you could, once you know where the check is in the image, you could compute what are called feature vectors. They're abstract representations of the contents of the image. Basically, it's a fancy way of saying, here's a list of numbers that represents this content in the image. And you could compare them to a known database of checks. And that way you could figure out which style of check is being used.
Ah, interesting. So my simple mind was thinking things in terms of, the check number would be proportional to this edge, but you're saying more the content looks like this, regardless of where it is on the check. It is always in this format, and that would make a much more flexible algorithm.
Mm-hmm. Absolutely.
You work on a number of different kinds of computer image apps, and one of them, which kind of brings us to this, is this notion of content-based image retrieval. What is that?
Content-based image retrieval is a very fancy academic way of saying an image search engine. So we're all familiar with going to Google and typing in some text for whatever it is that we're looking for and getting our result set back. But it's a little different with images. We can't manually tag and label every single image on the internet with whatever the contents of the images are. Instead, we need a way to make these images searchable and rely strictly on the contents, the RGB values, or some sort of abstract representation of these images. And that's where image search engines come into play. They're actually looking at the contents of the image and constructing, again, this feature vector, this list of numbers that abstractly represents and quantifies the image. So a great example of this is TinEye. TinEye is a reverse image search engine. and you go to TinEye and you say, I have this image. I want to know all the other web pages that this image appeared on. And you upload it to TinEye, and TinEye analyzes that image and then gives you the results set back. So yeah, CBIR, content-based image retrieval, image search engines, whatever you want to call it, it's all about extracting features from images and making them searchable based on their contents without manual annotations.
In the old days, when I typed cat and got a picture of a cat, was it not because the word cat appeared in the JPEG or the word cat appeared near the picture or they're guessing that it was a cat? It seemed like that got a lot better in the last 5 to 10 years. Like I remember I used to type stuff like that and find completely random, clearly not a picture of a cat pictures because the text-based system was determining that there might be a cat in this general area. Are you saying that Google Images really knows that's a cat?
Yeah. Google at this point really knows that's a cat. And it's funny that you bring up the cat example because Google used millions of CPUs on YouTube clips of cats to train a network to recognize cat pictures.
So you're saying that more power has been spent on the internet trying to figure out if that's a cat than any other animal?
Yeah, that is true.
That is insane. So you've got a really popular blog and resource guide at PyImageSearch.com. Now, is this like the Bible that I should read for getting involved in computer vision?
I wouldn't call it the Bible, but if you want to really get into computer vision and build some apps really quickly and learn a lot along the way, then definitely go on over and check out the blog, take a free crash course and poke around.
How long have you been doing this? How long have you been into computer vision?
My entire adult life, so I guess about 8 years, I've been studying computer vision.
And your PhD is in computer vision?
Yep, focus in computer vision and machine learning.
What was your thesis in, if you don't mind my asking?
It was basically how to build how to rapidly construct large-scale classification systems. And the example I used was the Boston bombing marathon. We had these images that were coming in so quickly from security feeds, from pedestrians with their cell phones, from red light cameras, and everybody wanted to know, is there a suspect in this image? And trying to have people manually sift through all of those frames in a video, that takes a lot of manpower, it's expensive, it's time consuming. And I thought to myself, is there a way that we can kind of do this type of stuff with computer vision? Is there a way that we could build these types of classifiers to say whether or not there's a suspect in the image? And that's basically what my dissertation focused on was, this is how you can build these classifiers. This is how you can do it better than the state-of-the-art methods, which take experts to tune the knobs and the dials and get everything to work properly, and really get a system out there very quickly.
Have you ever seen Person of Interest, the TV show?
No, I haven't.
In the show Person of Interest, they've basically made a giant super smart computer that has access to every surveillance feed in North America. And then they'll say, oh, we're looking for Adrian. And then it chews, and there's all these amazing frames that shoot by with squares around people's faces. And there we go. He just got on the subway. And then they all rush after him. It seems to me like that's totally possible given an infinite amount of computing power and an infinite amount of surveillance cameras. You could go and find someone by their face.
Oh, for sure.
What about if you hold a picture of your face, like up to a camera, and I'm going to lie and pretend that I'm you and sneak into somewhere that's using vision processing to secure a door?
So technically that's possible. That is a way to fool some of these systems. However, more advanced security systems are starting to use 3D modeling. So it'll be able to detect that's a 2D picture that you're holding up. It's not an actual 3D face in front of me right now.
Okay, so we would actually be able to detect that may be Adrian, but it's actually a picture of him.
Mm-hmm.
And does it do that based on like Connect, where I can see depth as well as color? Or does it do that based on he hasn't moved, and people usually move and twitch,
It's either a stereo camera like an Xbox Connect where it can estimate depth, or it's actually within the algorithm. It's trying to estimate depth based off of a 2D image.
That is very cool. So this resource guide is you've got an 11-page resource guide that's totally free up at PyImageSearch.com. And where can people get your book?
They can go over to PyImageSearch.com as well. I created a 20% discount for Hansel Minute listeners. So you can go to the PyImageSearch.com/HanselMinutes. So that'll be a 20% discount for the next 2 weeks. So if you want to learn the basics of computer vision, image processing, detect faces in video, recognize handwriting, or build a system that can recognize the covers of books and go off and compete with Amazon, this book can help you out.
Mm-hmm. And even though it's PyImageSearch and you're into Python and you use Python, you can use OpenCV and languages like .NET, C#, Visual Basic, can't you?
Yep. There is a library called EMGUCV, and that's essentially your .NET wrappers around OpenCV. You can also use IronPython, which is a tightly integrated open source implementation that integrates .NET and Python together.
Very cool. Well, this is great. I'm excited. I'm going to learn computer vision in a weekend now, aren't I?
If you set your heart to it, you can.
Thank you so much, Adrian Rosebrock, for talking to me today.
Oh, thank you for having me on. It's been great.
This has been another episode of Hansel Minutes, and we'll see you again next week.